to show you how to solve basic trig equations. Now what I want to do is take you back to the right angle trigonometry days where you learned how to find an unknown angle from a right angle triangle. And hopefully you learned that in order to work backwards and find out, well, what is the original angle, you had to use what was called the inverse of the trig function. So if I have a triangle, let's go 1 on 1 and root 2, and I wanted to work out, well, what's the angle here, I would go, well, okay, let's use the opposite and the adjacent, because this is opposite the angle, this is the adjacent. I could have used other things, but let's suppose I'm going to use tan. So I know that tan of theta equals the opposite over the adjacent. And to work that out, tan of the angle is 1 over 1. So to work the angle out, we would use tan to the minus 1 of 1, which tells us that the angle that we're dealing with is 45 degrees. We can also say that tan of 45 equals 1. So tan to the minus 1 is a way of working backwards and finding out that unknown angle. Now we're going to apply that to solving some basic trig equations today. Let me clear some space. Alright, let's have a look at solving cos theta equals 1/2. Hopefully you can recognise that this is an exact value, so we're going to need to draw an exact value triangle. If you haven't recognised that and you've got the calculator, you can go cos to the minus 1 of 1/2 and that will give you your angle theta. So let's have a look at the exact triangles. Now these are something that you should be familiar with. Here I'm going to draw an equilateral triangle and split it in half to give me the right angle. So I've actually got a 30-degree angle, a 60-degree angle, hypotenuse is 2, the base is 1, and through Pythagoras we know that's root 3. Because cos is to do with the adjacent divided by the hypotenuse, we know that that's the hypotenuse and that's the adjacent. Now, if we have a look at this, we can see that the angle has to be 60 degrees because 60 is adjacent to 1. So therefore we know that the angle of this solution is 60 degrees. Now you might think that's the end of the question. However, we have an understanding of the unit circle and understand that there are multiple answers that give us a half when we look at all the possible angles on the cosine curve. And one of the things that's important is you should be given a domain when you're being asked to solve a trig equation. In this case, let's just look at the domain between 0 and, theta, not x. Let's look at the domain from 0 to 360 degrees. Obviously, we're in degrees right now. You need to consider the case if you're in radians as well. So looking at this, I want to go all the way around the unit circle. We understand that in the first quadrant, cos is positive. We are looking to solve for a positive. So therefore, this 60 degrees is our first solution. So our first solution is 60 degrees. Going all the way round, we need to look, well, where else is cos positive? Cos is also positive in the fourth quadrant. So we find out what this angle is here, which of course is 360 minus the 60 degrees, tells us that the second angle, of which cos of the angle is equal to 1/2, is 300 degrees. And that's all the solutions within the domain of 0 to 360 degrees. Let's just look at one more that we're going to solve. Now this time I've got tan theta equals 0.8. What we need to do is consider we have a domain, we need to go from 0 to 2 pi. We're clearly in radians here. So if we have a look at the unit circle all the way around, we need to look at, well, where is tan positive between our domain that we're dealing with? Well, tan is positive in the first quadrant and in the third quadrant. So these are the two places that we are going to find our solutions to this equation. To find the initial acute angle, which sits here, we need to do tan to the minus 1 of 0.8. Now obviously I'll need to use the calculator for that. So if I use the calculator, I've previously done this already, we get theta equals 0.67, correct to 2 decimal places. Now, let's look at that angle there. We can actually say that this is a solution. So our first solution is 0.67 because it's sitting in this quadrant. You may get instances where this is not necessarily a solution to the equation, so you do have to be careful there. The second solution is found by taking pi, because remember this is pi all the way from the positive x-axis, plus 0.67. So you'd use your calculator. Pi is approximately 3.14. You'd add your 0.67 and you get 3.82. And that's your second solution. And that's all the solutions within the domain of 0 to 2 pi for this equation. And that's pretty much all you need to know about basic solving trig equations.